Hi everyone. Welcome to this talk about anti-fragility and secure coding through an architectural concept called domain primitives. A little raise of hands. How many consider themselves as developers? Oh, cool, cool. How many? Keep your hand up if you're also working with Typescript. Keep your hand up if you, in addition, are concerned with security. Oh, still very good. How many are writing their own tests? Fewer. Cool. I'm happy to see you all, and hope you get something useful out of what I'm going to talk about today. I really like questions, but make a note of them, and we'll take them after the end of this talk. There should be ample time. This cartoon is a famous one by XKCD. It has stuck with me, reminding me of how important input sanitation is. Anyone recognize it? My name is Sten Johnsen, and I have been with Bouvet for 17 years. I have been a programmer for a long time, longer than that. Working with software even longer when you also include roles like project manager and other management positions. Currently, I'm a DevOps trainer, full stack developer, and team lead. And I consider myself above average busy with the application infrastructure, automation, and improving the quality aspects of software. So, today I'm going to talk about anti-fragility, perimeter security, a little at least, security in design, domain primitives with some code example, and I'll throw in some do's and don'ts and personal experiences at the end. Anti-fragility. Anyone knows that from before? Familiar with it? Yes, a few. Cool. It was first coined by a guy named Nassim Taleb in a book called Antifragile, Things That Gain from Disorder, published in 2013. Anti-fragility is how systems get stronger when exposed to stress. Our body is an anti-fragile system. When we train, we are damaging the muscle cells a little, and the body not only heals itself, but makes the cells a little stronger than they were. So, picture yourself as a steel spring. A fragile spring will break under pressure. A robust spring will return to its previous form when pressure is released. An anti-fragile spring will be harder the next time pressure is applied. As mentioned earlier, anti-fragility is when the system becomes stronger when more stress is applied. For an application or an IT system, the stress is things like user load, unusual ways of using the application, changing package versions, and all the other stuff that might contribute to the system breaking down. The healing process is the routines, the practices, and the speed and the general mindset in changing the system. So I'll pick some practices that we tend to focus on. It might not be the best ones, or even definitely not a complete picture, but we have a few. Bugs. Bugs are stressors that we can gain from. If treated right, always start with a failing test. That's my go-to. Verify the bug. Add edge case tests when bug is fixed as part of the fix. Leave tests to continue being part of your test portfolio, so they run every time. You make sure this doesn't happen again. And also relate tests. Related bugs, that is. Mutation testing using Striker is a good way of verifying quality of your tests. Anyone using Striker? Anyone knows what Striker is? Mutation testing? Cool. I almost know someone then, because you're listening to my talk. We have been using Striker for a while. Striker is a mutation tool that actually inserts bugs in your code and then runs all the tests and then gives you a score on how many of the bugs they actually find. So a score very low means your test is crap. a score very high, it means their tests are pretty good. So I recommend keep your score at above 50% at least, and make it, or you can even make it a team goal, team game to increase it by 2% every month. But first, of course, you have to do mutation testing. A production bug should always result in an increased striker score, mutation test score, at least for the production files touched by the bug fix. Blue-green deployment is a must for no downtime releases. This means that the pods that are running your old code won't be killed unless the new code is actually running for a while without problems. Yes. Investigate failures. That's a fairly often missed point. It fails and then we fix something and then we go on. But investigate and find the root cause. That's really important. Even if just the redeploying actually fixes the problem. Back to the, security is my next point as well. Back to the initial cartoon, think about application security and make sure you can't pass drop table users where a project GUID is expected. Let's talk a little about application security. Even in DevOps, we teach that security often are particular activities like threat modeling, penetration tests, security reviews, static and dynamic application security tests, and so on. And all these activities are good and needed, but if we do not keep an architecture helping us maintain and improve security, we end up with a fragile or at best a robust application. And we want to aim higher than that, I guess. Or yes, we do? Yes, we do. Our understanding of building quality in is, among other things, a good architecture. So, Secure by Design is a book that talks about how design can drive security in software development and comes with many code examples to demonstrate that point. Anyone familiar with that one? Oh, I recommend this book. It's very good. If you're concerned with security, and a lot of you are, according to my initial poll, this is a good one. It's very focused on Java, but still it's applicable for any language, actually. So definitely, one of the constructs described in this book is actually domain primitives. In our team, inspired by this book, we decided to go for domain primitives in our next application when we implemented it. And that had some consequences, obviously, and I'll get back to that. So, what is a domain primitive? A domain primitive is a data type designed with the user domain in mind, as a contrast to language primitives, which are tied to what data types the programming language is busy with. And in Typescript, that's a number, string, object, boolean, stuff like that. It allows us to validate and protect every single variable in an entire application. That's really down to the core validation of data, not just perimeters. So let's get some context on this. Consider some frequently used example of input sanitation. So what I call the first line defense could be a simple input pattern matching in a form text field. These are simple, but easily bypassed if you just form post directly to the backend or something. Restricting input through sanitation functions, for example in the backend, this is better, but we have to remember to implement for all inputs. So this is now something we have to check and verify that we have. Strong form types is also an option. Language primitives restricting the data types of inputs, like strings, as said, numbers, boolean. Typically, these objects are tied to a specific form. And these are all nice, but the type restriction can be a lot stronger, in my opinion. Consider a front-end URL for rendering a report of a pipe of some sort, like this one. Everyone can see this one? I hope so. You can see, recognize the query string, parameters, project ID, and pipe ID in there. Typically represented as strings, but they're also GUIDs. In the backend, that would translate, or a backend call, that would translate to something like this API backend call. The get pipe data function receives a pipe ID and a project ID, and then passes it on to inserts it into the query string for the access get URL directly. If you do it really simple. So GUIDs are often used as lookup keys and sometimes used unsanitized in SQL queries. What can go wrong, you think? Without security in mind, this could open up for SQL injections, obviously. Access to the wrong project. Cross-site scripting. Authentication bypassing, duplicate keys, business logic abuse. You name it. In many other things, you just by altering the pipe ID of this thing. As you see, that's part of the query at the end, right? So when rendering the report, we are using the parameters, passing them on to the API for fetching data. Without type checking this opens up for a runtime errors and possibly invalid input, like this. This is probably one way of doing it, accessing the get pipe data function that I had the access get functionality. So specifying a primary type at least ensures that we don't have any other types passed. Explicit typing like this one prevents unintended values, like numbers, for instance. Catches potential runtime errors at compile time. And ensures project ID and pipe ID always behaves like a string. And defining a GUID like this one, like a string, means exactly that. They are treated the same. No extra type checking and no added safety, although readability is improved as we can understand a GUID is expected. So for readability, that's good, but for value checking, it's not so good. It doesn't really do anything for us. Adding type checking helps us make sure strings and GUID is not interchanged. So in this case, if the get from URL returns a string, we will have a compile time error, because that's not a GUID. Right? Unfortunately, what often happens is that we tend to bypass this by actually casting the output of the string, and then we're back to square one. There is no, the little we had of checking was actually, or guarding, we had is gone. So this means that any validation of the type has to be done manually, basically. So what I think is that the best thing to do this is to actually define a class, like a GUID class in this case. So this is a simple class implementation of a GUID. That's the basic one. By calling a validate function, we will always verify the input value, that the input value confirms the requirements of a GUID. The validation will throw an exception if validation fails. So we have a continuous validation of any data that is meant to be a GUID, right? For even better encapsulation, define explicit create method and keep the constructor protected, or at least private. So we define a specific create method, like this one, that ensures that we are doing the validation. So using that one would mean changing the code on the usage side there a little. The usage of this will then create the validate the data when introduced to the application. Every time it will be at the perimeter, right? Whenever the data is introduced into the system. So we arrive at something called a domain primitive. That's actually a domain primitive. A value object so strict in its definition that if it exists, it will also be valid. If it's not valid, it can't exist. So making GUID an abstract class enables us to create domain primitives that are not interchangeable and may help us keep parameters orders intact. So we create an abstract GUID class that is meant for inheritance. And then we can create a project GUID and the pipe GUID. The validation is the same, but they are two different classes. Which means that swapping places for pipe ID and project ID now would create a Typescript error if we do it. So then, why domain primitives? I have a few good points, I think. As we discussed, type safety. It makes the intent explicit. It's more easily readable what we intend to use the domain primitive for. And also helps us get the parameters right in the right order. No mixing without your linter or compiler letting you know. It will let you know immediately. Validation is done in one place. It's not spread around your code. So you will have the same validation everywhere, because it's so focused on the actual value you work with. And always sanitized, obviously, if your validation is good. Naming something telling of the role that the data will play makes it easier to distinguish it from other data. So we have said now that this is a project ID GUID of some sort, which means it should contain a project ID, basically. It's just not a string anymore. We can keep useful methods encapsulated within the class like this. That is keeping all the functionality that is relevant for that data within that class. So that simplifies the usage of the domain primitives a lot. In our case, we even add methods like create valid GUID that creates a GUID based on a short string. So, and use that for test purposes. So in tests, we just call that function, and then we have a test GUID that works and it's valid, rather than having just A and B and C, which is so yes. Copilot is trying all the time to replace GUIDs with A and B and A1 and A2 and stuff like this, and then it fails because the validation of the domain primitives is always there. But with this function, this helper function, it's easier to create those test variables. Also, using the same code makes sure we have the same type definition validation. No code duplication, as I said. In our application, we use the same common domain models and domain primitives. Implementation for both frontend and backend, because we have Azure Functions backend with Typescript. So we can use the same library for both of them, for frontend and backend. So keep the code, no duplication is essential. Encapsulation keeps things tidy and easy to test. Testing is important. We are proud to have more than 90% test coverage and a striker score of about 70% now in total for the application, which is helping us a lot. It's also a lot of work to maintain, but that's how things are. It's even more work if we let more bugs through and into production. That's a bad thing. But yeah, encapsulation makes the functionality very focused for the particular data type with very limited external dependencies. Makes mocking and stubbing for tests easy, I find. Encapsulating functionality keeps things tidy and easy to locate. For instance, converting GUIDs to a lowercase, that's normalizing to a lowercase, for instance, happens only one place. We do that when we create it. That's it. And also, I didn't mention it, but all domain primitives are immutable objects. So you can't change them afterwards. You should just throw it away and then create a new one, which also is a security aspect. It won't be changed on the way, right? And last, it integrates well with domain models and handling of data in an aggregated level, I find. Are there pitfalls? Yes, indeed. I'll at least let you know about our top 4. Domain primitives are brilliant as a detector of possible bugs. Make sure to handle runtime data errors in a proper way. Because compile time is one thing, but runtime is a different one. Don't let application crash because an object property was null when your validation expects it not to be. That has happened way too many times with us. And it's annoying because it also breaks production sometimes. It has done. So make sure you handle this in a proper way. Also keep an eye on the benefits of creating a domain primitive. Sometimes a number is just a number, and you might not need extra validation. Or a string is actually just a block of text. Might have a length limitation, but still, it's just a string. So use data types to your benefit on the level that suits you. That is, we create domain primitives when it's valuable to actually have this kind of validation and this kind of immutableness. Excess use of domain primitives, it increases your code base a lot, and then with that comes also technical depth and effort for maintaining all this thing. And the possibility of bugs obviously increases. So be careful and not overdo it. Yeah, balance that with the effort of actually using domain primitives. I was touching this a little also. Make sure you handle errors the right way. Unquote create will crash your app when you least want it. It's not a fun thing to experience. Use try create to make sure error is handled. So you just defined all the methods to do that. And create when you know what you're doing, or in safe spaces like in tests or in a clearly defined try-catch construct. All domain primitives has functionality that needs tests, but also domain primitives complicates your other tests. As I was touching into this also. Like you can no longer use any string as a GUID test data. It has to be a valid one, or you have to mock the actual domain primitive, which is kind of funny. I find it a little useless. Make the test effective and easy to understand by making test helpers, so you can use elsewhere. That's very good. Property-based testing is a recommendation. I find that useful. And if you haven't chosen your test framework yet, go for Y-test. Seriously. Drop everything else and go for Y-test if you can. It's so much faster. So a little at the end, what we learned. Always catch your exceptions in a good way, in the proper way. Make your domain primitives easy to use. That's important, because we're just humans. We tend to not use them if we find easier paths. And the other flip side of that is be restrictive when reviewing. Not too easy, but also make sure that we're using domain primitives on the right spots. And use any bugs to make your application stronger. That's my kind of anti-fragile tip for today. So I'm pretty close to the end. Anti-fragile systems get stronger from stress. We went into that. Stress factors for software is anything that can break it. To sum it up. Healing process includes how we treat bugs or hacking attempts. This is our process that makes the application stronger. It won't do it itself. We have to do something for it and be mindful on what kind of processes we choose. With domain primitives, we secure every variable, as I was mentioning, not only perimeters. So it's just not a perimeter or fence kind of protection. It's actually every time you create a variable, a domain primitive variable. And I've shared some experiences with you, so I hope it's been valuable. Thank you.